Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. Today we're going to continue with our Velleman kit construction. And like I said in the earlier video where I showed you this, it was something my father bought. I think it's for an audio type project. It appears to be a power supply, effectively that. It has a maximum of 224 volts. AC inputs, and there is a transformer that comes with it. There's still a Velleman as well, and it's 2 times 12 volts at 1 amp. So it's a pretty decent power supply, and it has a pretty decent heatsink, which was optional. So this has all of the accessories with it. Ooh, this one actually has a diagram. If you remember last time we had to go online to get some of the instructions, it's nice to see this one. So it looks like you have your power supply here coming in, which is indeed then going through rectification. And where's that coming? Going through there. Well, we can see here you've got 2 regulators basically. And a little look at the data sheets. Yes, the LM337 is the negative regulator equivalent of the LM317. So yeah, you end up with a plus and minus. So that makes sense. So if you wanted to use just the positive component, you'd go from ground to plus. Or if you wanted to use the negative, you could go from ground to negative. Or I don't know what happens if you use the plus and the negative. It's like the power combines and then you get nothing. Right, let's just get on with it, shall we? Oh, I did it again. They've got that crazy lid which just dropped everything. Which is okay, I suppose. They have to be very careful when they're putting all this together, don't they? Don't drop everything all over the shop. Right. Fortunately, there's a bunch of diodes because there's a lot of rectification. It's like a power vamp in that respect. There's some wires here, and that's probably because it's a single-sided PCB, so they've got lots of jumpering going on, and it does indeed look like we have to add those in. A couple of electrolytic capacitors, and then we've got our regulators. So in case you don't know, depending on the type of regulator, and I should have really checked that up, these probably adjustable actually. I think these are adjustable because you do have the pots. They take in a voltage, a DC voltage at this point, and then they'll convert it to another one. So they'll take, say, 12 volts and convert it to 5 volts. And in doing so, as part of that conversion, there is some inefficiencies and they do get hot. That's why you normally see them having a big old heatsink here. You often buy regulators in standard fixed values, so you might get a 3V3 or a 5 volt, 12 volt, maybe a 9 volt, yeah. Or you can get them in their adjustable counterparts through the addition of some additional components, normally resistors. You can change the values, and that's why on this we do have these, here they are, adjustable resistors, and these will allow you to tune it in. So yeah, it's a little variable power supply. If you recall from previous Velleman kits, you go online. I did check, there isn't any more instructions other than these. You have to go online to get the full assembly instructions. However, I'm feeling a little bit brave, and I'd like to see how much of this I can accomplish without them. I can tell pretty much that it's going to be totally plausible to do that. But the only issue is that there are a couple of different resistor values. So we might see if we have to work that out from the schematic. But other than that, I don't think we're going to have too much of a problem. So the first thing is preparing the diodes. We've got plenty of them. And those will be really easy to put in there. Oh no! If you get the spacing right. So if you've got a tool like this for bending the legs, don't do what I did. Just pay a little bit of extra attention so that you get them the right width apart. Otherwise you'll have to do a little bit of wiggly pokery. It's not too bad though. At least this stops them from falling out. So I'm just going to throw these in, and then we'll have a go at soldering them, and that way we can see, we'll get an idea really of how these boards are when they come out of the kit in terms of their cleanliness. Hopefully it'll be nice and clean and the solder will flow. Like I mentioned before though, if you do have any suspicions that the board might not be entirely clean, just give it a rub over with some IPA or a little bit of an abrasive cloth, you know, like you might use in the kitchen. Just shine up those pads, but just be careful you don't want to get rid of any silkscreen, although yeah, it's pretty heavy duty on here. So that's the last diode. You can see they're not falling out. I wonder if we can actually just get everything we want from this picture. That would be interesting. So we have to solder those in. Got a lot of dead legs sticking up there. I've set the soldering iron to 350 degrees C. Yes, that's perfect. They're such a good kit in terms of the quality. And you can see that one took quite a long time to solder. That's because it's on the ground plane, and you really get to notice that if you're using small soldering irons like this and you're doing particular boards frequently which have, say, ground planes and normal signal traces, you really get a feel for it. You know exactly which contacts are going to need that extra time. So if you're doing one, just make sure you do spend that extra time, because sometimes you'll end up with a dry joint where you rushed through and one of those pesky ground planes sucked out all the heat before your solder got to flow where it wanted to. We're not doing too badly here. You've got a nice amount of room between all the components. They're really spaced out. I don't think there's any chance of you making too much of a mess of one of these. And it's quite a handy little thing when you're done. If you're working around with any audio projects, you always need that negative power supply, and it's a bit of a pain. You might have seen the video for some of my retro power supply mods where I've had to make effectively a negative power supply or a negative power rail, and it's normally not particularly trivial to do that, especially if you want something that's got some current behind it. Just chopping off all those legs. And I'm hoping, I didn't double check this time, but I'm hoping I don't have any components that's sitting too high off the board. If you recall, I tend to do a little tack and then flip them over. Make sure they're sitting flush before I finalise the soldering, but we're good. Look at that, that's good. So I'm just going to chuck in all the components that I definitely can figure out where they go. It's really hard to go wrong with the old big electrolytics. They have the positive marking on the PCB, and you know the long leg is positive and the can is marked, so you have to really go in some to get those wrong. Now we do have some smaller electrolytics. If they're different value from each other, that could be a little bit of a problem, so let's check. We have a 10 microfarad, 10 microfarad, 10 microfarads, and if we're lucky, 10 microfarads. So there's not too much ambiguity there. You can see those quite clearly. Two. So I might have to tack solder those because those are very jiggly. There's the last one in there. As they are loose, I think it is worth soldering them. I'm just going to gently put it like that, sitting. Hopefully they haven't fallen out too much. Oop, one just moved. I'm just going to solder one leg on each. Very gently. It's not even a proper solder, it's just it's kind of the worst solder you'd do. If you're a bad solderer, that's what they'd look like. And that one's on the ground. No, there we go. So you can see that would be pretty miserable. I've actually seen boards where people have sent in with issues, and they're like that. Some of the components, you're like, okay, you had a go. Fair enough. Don't beat yourself up too much about it. There are plenty of people out there who love to criticise soldering for some reason. Just ignore them. One more here. These are nice and easy because you can press them hard onto the deck. You know they're flush. You've got that another ground. It's taken its time. And let's go in and hit those with their final solder. Might be able to prop this board up. There we are. See the board's jiggling around. It's ready to dance. That looks like a good job to me. Let's pop the variable resistors in. They're both the same value, conveniently. They look like they'll hold themselves in. Yep. And we have a couple of electrolytic capacitors, sorry, ceramic capacitors. We might as well get those out of the way while we can. I really hate this packaging. I'm trying to work out how it does it, if machines cut these. Once you've had to pull, 200 of these off manually out of that paper, your mind does tend to wander on how they do it in practice. I was avoiding it, but we do have to figure out where those resistors go. So we have two 2K2 resistors on the output here. And then we have two that are nearer the actual regulators and they form part of this feedback circuitry, I should imagine. So we have 2K2 ones here and they're going to go near the exit. Let's see. Oh, they're handily. Actually, it does say R3 and R4. So this really does have everything you need, actually. You don't really need any more construction instructions. In fact, look, this is page 14, this diagram. I wonder if my dad printed this out. Anyway, it doesn't matter where it came from. It's going to do the job. R3 and R4. So let's get our benders. We just got to slip these in. And if you ever need to, get yourself some nice little tweezers like that. They're super handy, especially if you've got to get something in there where you've already put the components down beforehand, which you probably shouldn't have. But it happens. I mean, if you're doing a repair, you'll have to be able to do something like that retrospectively. It's not a big deal. Look, it's done. Even if you had to do it by hand, you'd get it in eventually. If you're ever intending to do any sort of surface mount work, though, you might as well just get the tweezers now. It's all pretty much assembled now. There wasn't really any gotchas with it. It was all fairly simple, apart from just one little jumper that I had to put in there. And they provided plenty of those jumper links. And you can see on this board, there's jumpers going across here. They have 6 of them. And the reason is, either you're going to mount your regulator here, or you're going to mount it outboard. And that depends on your heat sinking solution. I think the best way to figure out what we might need, though, is to actually take the heat sink and start eyeballing it. So it actually says here, optional heatsink, Velleman. Now, I would say I would prefer the heatsink here. So it's actually on the material of the PCB. And you can see it does have holes where you'd actually screw that through. However, looking around here, I don't see any hardware at all with this heatsink. So I don't know if that's something missing as part of the kit, or maybe there was a little bag that got lost. So I'm going to have a quick look around to see if I could figure that part out, because it would be nice to mount that first before I solder anything on there. And of course we're going to have to mount those regulators as well. Got some assembled hardware now. The tricky one is going to be getting these self-tappers to eat into the heatsink. So I think before I do anything else, I'm going to try to start those off. Now these are self-tappers. If you're not aware what a self-tapper is, you can see it's a standard panhead type screw, but you have a very aggressive thread on it, a bit like a wood screw, but it's harder, so it should bite into the metal and then form a new thread. Of course, if you have a tap and die set, you can have a go at that. If you have a machine screw, you can hear it, it's biting in, and I'm providing a lot of force because you don't want it to slip, because if it slips on that screw head and rounds the screw head, you're really scuppered, because there's no way you're going to get enough torque to go further, or in some cases get it back out. So it's always, see there, it slipped just once. Again, I let my guard up, and that was on taking it out, and it slipped once, but it's okay. There wasn't enough torque to damage it on the outward twist. And you can just about see in there your nice new threads cut in. And I'm going to repeat the same. Sometimes I'll take a fresh screw actually, rather than reuse the same one, just because the edge can be damaged, but because this is a soft-ish aluminium, it should be okay. Look at the angle of that. If it was parallel, it would be better, but I'm hoping it's going to pull itself in. And you could see how much extra torque I need. And if it goes wrong, that screwdriver's going through your palm. Oh my word. That is hard work. The heatsink is biting into my hand in every which way when I'm trying this. So gloves could help too. In fact, I can't do it. I've got to get some. That's it, it's jammed up. Let's take it out. So before that one gets totally ruined, I mean, it's not ruined as a screw. We can use that at the end, but I think it's ruined from a trying to cut a thread perspective. So I'm going to put that brand new one in. And if you have it, any cutting compound, you could try putting that in. Cutting lube, whatever it's called. Tries to reduce the friction. Yeah, look at that. And you can see that, how that one just made short work of it. So really, they are like knives, they dull. So VR1 is the positive regulator and VR2 is the negative regulator. So VR1 should be the 317, which that one is. Pop that in there. And then this is a 337. Put that in there. And you can see the different brands. The one on the right is a ST, and I always like the ST things. I'll use the most advanced ones they do because they're really great specs. You can look at the shape of it, you can look how it is, but look at this one. This is El Cheapo one. But I'm guessing it's just because they're a bit rarer, right? You can really get your hands on loads of the ST things, and they're quite expensive, but maybe they're not investing quite so much in the negative going on, but that's fine. So I've pushed those all the way in flat. I'm going to put that heatsink all the way, and look, you can see those holes aren't quite lining up where we would want them to line up. So I'm going to scratch my head a little bit and think, how did they intend you to fit these? Unless this heatsink came with some sort of plastic riser kit, right? There's no way that you're going to be able to make up that at least 5-6 mil gap. So maybe they made a mistake here on the footprint for this. Maybe they intended to make the holes a little bit bigger so the regulators would sit totally flush. I think we've got plenty of meat on the back here, so that's what I'm going to do. I'm going to drill out these holes so these regulators can sit flush. So I'm really glad I tested all this up beforehand. I've got a drill bit of the right diameter here, so I don't have a handle for it that's this small, so I'm just going to do it by hand. It's going to take a little bit of time, but not too long. You can see already it's making the hole, and there's plenty of meat on that pad, so you can still solder it nicely afterwards. And of course, the nice thing is, because it's single-sided board, we know there's no vias to worry about. If there were vias, then this would be, and this was through plated, you'd have a lot of problems here. Well, at least you'd have to make sure the top and the bottom were soldered, which is going to be really difficult if your regulator's sitting flush. Time to give them a wiggle, I think. Now, I didn't measure really the height up to the hole on the heatsink, so let's hope that this takes up the appropriate amount. You can see that's poked through quite nicely. We'll have a look at the solder pads when we flip it over. That's nice. Look, that's a really nice flush fit. Still not quite. Still not quite. Still about 3mm gap. What can you do? We'll have to figure out something to add there as a spacer. I think we'll just solder these in as is. We definitely wouldn't have want them flopping around like they were. And we're just going to make sure we've got a nice bit of solder on each one there, because we have made the sidewalls that bit thinner on the pads. Not a big deal. There you go. I'm almost tempted to drill out the pads on the heatsink, you know, those holes. If you're doing it and you intend to drill out holes, just do it from the beginning. You don't need to do any of this PCB hole malarkey. It'd be an unnecessary step if you're going to go through the effort, because you can put the holes wherever you want. As for me, I have to take the existing ones now and drift them out, which might be not as nice a fixture when you're done. I couldn't live with myself, so I did drill out another couple of holes, and I did cut a thread into the other side, because of course we have to flip it on its head. That's okay. So what I'm going to do, I think, is offer up some of this hardware, make sure everything lines up. It does look pretty good. It is pretty aligned. Sometimes putting these through at the end though could be a bit tricky if you've got little nuts and bolts to tighten. So I don't know, there's no particularly great way of doing it. So I'm going to add these little silicone thermal pads, and these are designed to provide a better connection between the regulator and the heatsink. This one's got an annoying little chad in there. Phew, I have to rip that out with my bare teeth. So we've got that there, we've got that one there. I'm going to place this gingerly on like so, and then I'm going to feed through a couple of the machine screws. Hopefully they're long enough. Balls. Okay, right, let's try that again. So I've got the pads on the PCB. I'm trying to put my fingers in here to push these down. Struggling. It's not enough room for two fingers. And then I'm going to line these up. Hopefully I can sandwich everything together. Look at that, he did it, he did it. And there is just enough thread. Who'd have thought that, eh? Who'd have thought that? So I'm going to try to figure out how to hold, oh my gosh, all these things at once. This is a bloody nightmare. Let's get that there. Maybe some tweezers on the end of the nut. And I know at home you're thinking, well, you don't need to see this. This is the perfect point for you to skip ahead in the video. But it's like, no! If I'm going to suffer it, so will bloody you. Come on, get a bite, get a bite. It did, it got a bite. Nice. So what I was doing there was basically twisting the screw whilst holding the nut in roughly the right position. And the idea being, hopefully, it'll just catch. You just need one part of a thread to catch and you're golden. Look, that one caught right away. He's good. He's almost too good. So those are nice, they're not going anywhere. You can tighten those at your leisure. I mean, you've got to fit a little tool in there obviously to stop the nuts spinning so you can get on there, but that's not bad. That would probably work as is now anyway. Right, let's get these bits in. So this is where all that alignment becomes critical, because if any of these things are wrong, something's going to break or get bent. And the most likely thing to break or get bent, of course, is our regulators. So fingers crossed on this one. A lot more torque than I was expecting on that. Let's try his friend. Oh, you can see that angle. That's not right. That's going to want to push everything around while it's trying to turn. Come on. It's doing it. It's not digging it, but it's doing it. Whew, we're going to get there. I'll not lie, that did take a fair bit of turning to bite those up. About there. Just going to tighten these inner ones. So that's looking nice. So solid. What I might do is just heat these pads a bit. Just in case there's any stress on those regulators, I'd like to give them the opportunity to adjust themselves. So I'm just going to reflow these. I can do a couple of pins at a time to make sure they're giving a fair stab at it. But there's no sign of them moving. In fact, look at that. I really gunked up the solder, so they're basically absorbing all the heat now because they're sinking immediately. So I've turned the soldering iron up to 500 degrees now, so I can get enough heat into each of these pins individually. There we go. No cracks, no creaks, they're probably fine. It's time to test this bad boy out. So we do have this transformer. I'm presuming the two red are the hot mains in. So we've got our VA and our VB, and remember it's alternating, so there's no positive or negative, but you do have this center tap here, which we want to be in the 0. If you look on the diagram, you've got your A and your B, and you've got the 2 in the middle are a 0. They gave you an extra terminal for free, so let's start with one of those. That's the 0, and of course this is mains, so really don't use metal-handed screwdrivers. That tends to be a bit of a no-no. Certainly if you've got anything live, definitely do not. Get that good old crunch down, crunched. So there's our wires there, and then we're going to have to connect them to the mains. And that bit I'm going to do off camera because it's a bit naughty. You can see we're set up now. We have everything hooked up and it's producing enough current to spin a motor, which is great. It does say 2 times 12 volts out at 1 amp capacity or capability, so I'd expect that to be moving a lot faster, but then we don't know how to set this up yet. So I'm going to measure from the common, the center, to one of the outputs from the transformer. I'm seeing 2.6 volts. And now I'm seeing nothing. Okay, so we saw that the transformer was all hooked up and now it's stopped, but this is pretty damn warm. Surely it shouldn't be that hot. No heat off this at all. This transformer really does smell, you know. I think I may have done a bad thing somehow. So 1.4 ohms to one side of the output. 1.5 ohms the other, so that's fine. I think the output's okay. Let's look at the input. Now, being aware if you use your hands, you might bring something into the circuit there. In fact, look, if it's just me, 0.6 megs. So if I hold that there, let's see what we get. It looks an awful lot like an open circuit, basically, because take that away. It's just exactly the same. Wow, maybe I blew up a transformer. It has a very distinct hot, varnishy smouldering type feeling on it. Okay, let's go back to something else. Let's try the bench power supply. So I do have a bench power supply here, and if we just, it's DC of course, but if we hook it up, it should still work. It just won't make full use of the full weight bridge rectifier that's on there. I really, I'm quite surprised about that. I mean, that's still, they're not cheap power supplies, they're about £13. But I suspect maybe this circuit was doing something. Maybe it was effectively shorting it out, and this is sinking heat a lot better than that. But then this is absolutely stone cold, where this feels really quite hot now. It's almost like it's getting hotter as it's sitting there. Maybe something deep inside that transformer is working its way out. Come on, get in. There we go. So now we're hooked up. Again, put the bench power supply on, and I'm going to set it to 9 volts. Yep. Okay, we can see the fan running around right away. So maybe it was just a duff power supply or something. Zooming in, I can't quite, it's very dim. I swapped out the red LEDs for green ones because I thought greens would be aesthetically pleasing, but it's very faint. Very faint. I'm going to hold the fan there. Look, can have it cooling itself. But in the meantime, what I'm going to do is play with these adjustments. So we had 2 of these. I think this is the one for the positive. Well, you can definitely see there's an effect there. It's moving quite slowly, and then as I increase it, it's going faster. In fact, the bench power supply says it's drawing 2.6 amps, believe it or not. 2.6 amps at half a volt. Sorry, at 5 volts. 2.6 amps. Where is it all going? It's hard to believe, isn't it? In fact, I can't even turn the voltage up on the bench power supply because it's clamping it down so much. Wow. Maybe I've done something wrong here. This thing's driving me bonkers. As far as I can tell, everything's fine. It definitely blew up the transformer, and it's definitely only on the positive voltage side. So I was just looking at it and I was thinking, hang on, what if the casings of these shouldn't be touching? So let's try that. So I've got the bench power supply on. Nothing. Now let's turn this up. Oh my word, that's what it is. Holy smokes, guys. That's crazy. So it's the heatsink where I actually put a metal screw through there. It's been shorting this part of the casing to that part of the casing, and frankly I don't know where they hook up on those. So on the LM337 and then on the LM317, they're not the same potential, basically. And that makes sense because effectively they are floating, but the fact that they are connected to something is very worrying. I'm going to have to find a plastic screw, and I think I've just killed a 16-pound transformer. Okay, but at least we can make some progress now. I've created my own insulated screw, so hopefully that will work. So let's put that in. I've reversed the position of the nut, so the nut is now on the other side because it's going to be a bit too tricky to get that. But you can see that it will be insulated from the regulator and should work. Oh, the moment of truth. Let's hook up our fan again. Wow, so that is a seriously annoying gotcha, right? I'm going to go look in the instruction manual. It probably is in there. At least I fragged a power supply, or a transformer rather, so that you don't have to. And this one's still warm, believe it or not. It's still warm. Right, so our bench power supply is on 12 volts, turned off. Let's turn it on. Boom. There's our fan. I've got this now turned to the minimum here. So I'm going to crank that round. Whoa, okay. So what I suspect is happening, and I'm just going to take our fan out of circuit here, is that this fan's probably rated to 5 volts tops, so that's why it's going to go mental like that. So what we're going to do is just put our power supply here. Let's just take some measurements. So the input voltage is 12 volts. Pretty good, actually. It says 12.46 on our bench power supply, so we're only 0.1 volt out. So you can see there 1.2 volts at minimum, and then as I turn the adjuster, the LED actually gets brighter, and you can see you're tending towards your 12. And if we max it right out there, where do we go? So we end up at 10 volts, and that makes sense because you always have a drop across your diodes and you lose a little bit in the regulator itself. So pretty cool. You could actually, I know we've got these trim pots here, but you could actually probably panel mount those as normal potentiometers, panel mount ones, and get some goodness. Now unfortunately I can't show you the negative voltage component of this because I don't have a negative a transformer with the center tap anymore because I blew it up. But it would be exactly the same process. You would just adjust its voltage here in the same way, and its LED, which is mounted the other way around, would also glow. But really be careful of that gotcha there. That was a big old gotcha. So I might invest in a packet of plastic screws for regulators because it's something you never really consider. But whereas something like this has really hit it home that you could have a gotcha like this, and imagine trying to figure that out, and if you were completely unaware of it ever being a possibility as an issue, right? You just screw everything together and you'd be like, wow, something's blowing up, and you wouldn't even be seeing it getting hot because it's connected to a heatsink. That's basically had the 2.5 amps running between here, and this is just going, no problem at all. Anyway, all's well that ends well, I suppose. I can get on now with my life. Thanks for watching.